The first question that we are going to confront in our statistical analysis today, the first type of question that we can ask with respect to our data, is whether an observed distribution that we see in our sample corresponds to an expected distribution that we expect to find in the general population. These types of tests are called also one-sample statistics, because in order to conduct them, you only need to have one variable. And for this variable, you are trying to test whether some property of distribution of this variable in your sample corresponds to an expected property in the population, or it does not correspond. So hypothesis H0 for all these tests states that your observed distribution is drawn from a population with an expected property, for example, with a mean score of 3. And H1 says that your observed distribution is drawn from a population with a different property. And this property can be, for example, a mean or variance or any other property of your distribution. So in order to conduct these one-sample tests, these are just some examples. You need to have a single variable, and for this variable you are interested. For example, if it's a nominal variable like day of the week, imagine that you are working in a hospital as a doctor and you have different numbers of patients coming from on different days. And you can ask the question, are the differences in the number of patients coming on different days just random, non-significant, and you can assume that your distribution comes from a population with a uniform distribution. Or this difference from uniform distribution is significant, and that would mean that you need to have more doctors on some days and fewer doctors on other days to accommodate for this. Or if your variable is interval, for example, you can ask a question, is the distribution normal? And this is also a frequent type of question that we ask when we use one-sample tests. So just as a few examples, if the variable that you're interested in is binomial and it only has two levels, for example, a gender, male and female, or results of a coin toss, heads or tails, орел решка, then you can test whether this observed distribution is different from an expected distribution with an equal probability of both outcomes, or you can set this expected probability to be very specific. And this is exactly the test that we used last time when we performed the Cinderella experiment. In SPSS, binomial test lives in analyzed non-parametric tests binomial, and as a result you get a significance level. Sometimes you might be interested in more specific assumptions of the shape of a distribution on a nominal variable. For example, you have a nominal variable with many levels, for example 7 days of the week, or 20 different parties, and you want to test whether the number of people who voted for each party is the same in the general population. In this situation, you can apply another test which is called one-sample chi-square test. And it lives again in analyzed non-parametrics, and there you set your expected distribution, which can be either uniform, and automatically it will calculate an expected distribution with exact number in each cell. Or you can enter this expected distribution manually, set it arbitrary, and then you can also test against this. In case if your distribution is ordinal or interval, you might be interested also in whether this distribution corresponds to a normal distribution. And for this test in SPSS, you use Kolmogorov-Smirnov test. Also in analyzed nonparametrics, one sample KS for Kolmogorov-Smirnov, but there are also other tests that you can select there, and you can set different types of expected distributions, like uniform distribution or normal distribution or exponential distribution, basically whatever it is that you want to compare your data to. Most often we use this for normal distributions. And some one-sample tests can compare your observed distribution to a population with an expected distribution parameter. For example, is the mean score that I'm seeing in my sample statistically different from an expected mean in the general population? For example, you have a response scale from 1 to 4, and you can test the hypothesis whether the responses on your scale are different from an expected mean, which would be 2.5. Sociologists sometimes use these tests to make an argument that people are more likely to agree or to disagree with a particular item. In psychology, we don't really use this often, but in principle, sometimes you can encounter it. So I did not spend much time discussing those one-sample tests. I hope you get a general idea and the general understanding of hypotheses that they test. They test basically the hypothesis that our sample is drawn from a population with a specific property, like normal distribution or a mean score with a certain value, or a uniform distribution, etc. And these tests are fairly rarely used. But sometimes, if you really need to use them, you can always come back to this lecture or just look around in SPSS and you'll know where to find them.